Well, again, thank you everyone for joining us here today. Just echoing what others have said. It's nice to be out and about again. Normally, when I do these types of presentations in the most recent future, they have been done without pants. So it's nice to be doing that again, to be wearing pants. Uh, I apologize. We got to break the ice a little bit, let everyone get involved. Um, So again, thank you. Welcome. Just a little bit about who I am real quick. My name is Seth Helgeson. I'm a solutions architect here at IONOS. And throughout my career, I've been many different things. Started as a field tech, a sysadmin, network engineer, a business owner, a startup founder, and many things in between. And all of those things I have either succeeded at or quite often failed at. And I think that that's what has taught me a lot of the technology that I've learned today. One of the things I like about being a solutions architect is that I get to talk with people like you all of the time, customers, everything from a WordPress issue up to petabytes of data replication that need to get done. So I get to hear many different use cases, many different business problems, and many different fun things I get to pull apart as like a puzzle. So I really enjoy that, and it keeps me interested in learning things every day. Um, as part of this, what I wanted to do in this conversation was, as part of learning, go over things I thought that I knew inside and out. Um, I've been in technology for so long that I was pretty sure I understood how applications were built and how networks are run and how data centers are put together. But in going through things, I'm constantly, again, learning new things. And one of those is around kind of what's happening right now with applications and architectures and trends. What happens as a solutions architect is I will have many a call that starts off along these lines. I want a DevOps, CI/CD, Agile, Lean, Scrum framework. Now, obviously, by the reaction to that, everyone thinks that is okay, but there are many different competing frameworks within that conversation. And really, what the questions end up coming around to after we flesh things out a little bit is, you know, all right, I'm really trying to create a team that can iterate quickly and that's going to bring a product to market very fast. All of these other buzzwords, they are buzzwords in that sense, boil down to that type of question. So instead of leading with what someone actually thinks that they want, we have to take a step back and look at that question more holistically and develop this real question. Um, in order to answer both of these questions, we're going to do a little bit of a history lesson, and I think some of you will be happy with this. Some of you that are younger, just turn to the nearest gray-haired person and ask them what I'm talking about, but we're going to start at the beginning with fun things. Before there was an internet, there was a really cool thing called bulletin boards.
I had one.
Yep. Yes, and bulletin boards were awesome. This was the first place that we were able to dial in with a modem that went really slow. Most of you probably don't know modems now. Yes, get in really slow, and you could chat and upload really small ASCII files to other customers and show them really cool things, and it became incredible. This was the connected universe that we had all believed in and knew that could happen. Uh, some of these bulletin boards turned into huge infrastructures like America Online. America Online, interestingly enough, yeah, we all say, oh God, this is, by the way, why I like doing these types of things, because I learned all of this old stuff again. But as recently as 2015, America Online had 2.1 million dial-up customers still. that accounted for 200 million a year in revenue. All of those were still around. Now, a lot of it's been brought down from people like Elon Musk throwing up cheap satellite communications and things like that. So broadband has been brought out into these rural areas that only had AOL, unfortunately. And if you were really lucky, you could also, go into a Gopher site. For those that remember what Gopher is, that was the ultimate. You could find plenty of things that way. But digress a little bit. So in the beginning, after the bulletin boards, we got this thing called HTML, hypertext markup language. What is it? It's a way to make things pretty. And yes, I totally believe that Comic Sans is a professional font. It can be used everywhere, without exception. HTML was basically, it is a way to produce the same experience on many different computers. It is a portable format, went to many different things. You could run it anywhere. Mostly because of the Mosaic web browser. Mosaic web browser was the first browser that would bring up HTML displayed in a nice format. And we got incredibly useful sites like the Hamster Dance. This was a real site, by the way. That's all it did. The Hamster Dance brought us to the next level in terms of HTML coding that was out there. These hamsters would all run on a really old system buried in a basement. If you're lucky, a basement, sometimes in closets that were really hot. And these are actually very well organized in the grand scheme of things. Some of my partners who are here today have seen me put in way worse rooms than this in the past. So I'm just throwing that out there. But the building out of these data centers and these computer rooms were so that you could have one single box that ran a web server. And that's what that Hamster Dance site got generated on and came from. And no one in the business cared whatsoever that that thing was running. I mean, why would they with the Hamster Dance? But these old systems in old rooms really provided the first entry of these websites. The original incarnations of them would run on Linux. We would then take either back then a custom web server built by someone else, or another player started coming into play in Apache. And Apache was really the first web server that came out there. Apache came out as an open source license. Open source came out at this same time with Apache, where you could, I'm going to trip over these cords, I know it. You could run this Apache web server. You could make modifications to it. You could do all sorts of cool things. But if you did anything to it, you had to push it back up to the public code repo so that anyone else could do the same thing and see what you did. So it was the beginning of open source. The open source architecture started by Apache. I'm looking at Lakshmi because he's going to say, you know what, you're wrong on a couple of these. But the open source license that was started by Apache then led to many other open source licenses. So there's not just one open source license. There's many different frameworks that all of these architectures started to come into and evolve with. So that Linux open source architecture was maintained under an open source license. We then expanded into switching and routing and firewalls. These were all running open source as well. And the big one, databases were going open source. Prior to this, one of the databases would be IBM. You could have a DB2 instance, or Oracle, and it's really old days. But with the addition of these other open source licenses in Linux with the operating system, Apache with the web server framework, MySQL being the database service, and PHP, you'll notice there's no H in here for HTML. I'm going to talk about that in just a sec. But the P in PHP gave us the LAMP stack, which was popularized by the Bible of internet and coding skills in the O'Reilly books. They still make these O'Reilly books, believe it or not, and they are still very helpful. But with these, this developed what we would call a technology stack. And O'Reilly really actually coined the term a tech stack and started with LAMP as the first tech stack. So now we take all of these, turn them into a cool acronym, and we've got a great name for it. With this tech stack, this gave us the first entry into the code on top of code on top of code that has started. So like I mentioned before, there's no HTML. It's not LAM, however you would pronounce it. Intrepid developers found that in order to create our awesome hamster dance site, it required thousands of lines of HTML code. And that's just really too much to do. So instead of doing all of that HTML code directly, why don't we just write another programming language called PHP that will create all those thousands of lines of HTML code for us, and we can do it in only a few lines of code. And that's where PHP came in, to generate that HTML code that would ultimately be piped to the browser, because the browser, at least at this point, I'm not going to get into the weeds on some of these things, but because there are tech people here, the browser is just taking HTML and later on CSS and those things. It doesn't care how it gets it, but that's how it's going there. With this LAMP stack, the LAMP stack in particular, this revolutionized everything the way that we were doing. Everyone started coding for and using the LAMP stack. And that is why all of you know, I know Craig does, know why PHP is so important today. You've all heard lots of PHP. And I think this quote by the creator of PHP pretty much sums it up. I don't think it's deliberate that PHP gets very little press. PHP is about as exciting as your toothbrush. You use it every day. It does the job. It's a simple tool. So what? Who wants to read about toothbrushes? Well, apparently a lot of people want to use it. They just don't want to read about the toothbrush. So I wanted to give a little love to PHP that's out there. During this time, surprisingly enough, corporations came in and figured out that, you know what? A lot of people are using this LAMP stack. I bet there's money to be made in there. And corporations came up with their own types of architectures. And really, they're just applications that would build web pages for you. Some of these, we all know, they're incredible innovators like Flash, Silverlight. Silverlight is still around, as much as I wish it would die. Original Java, which is not JavaScript. Just make sure everyone knows that. Front Page, that was also one of my favorites. And our first in artificial stupidity and clipping. Yeah. We all hate Clippy. You can't, as a tech presenter, you just have to throw it in there. It's so a lot of these commercial implementations did have success. They found a niche. They served a particular commercial niche. No one gets fired for going with Microsoft. No one gets fired for going with, well, Macromedia, then Adobe, the Flash chain that became, until Flash became the mother of all security holes, which we all enjoyed. No one got fired for those things. But what did end up happening is that another player came into play, and that was JavaScript. JavaScript, by any calculation, is the most popular programming now in the world, no matter what you're looking at. It runs everything. And again, this is not Java. Java is totally different. We don't even talk about Java. That is not me this time. This is JavaScript. So JavaScript started around the same time as the LAMP stack and PHP. It just didn't really gain hold until sometime afterwards. I don't know the specifics as to why. It just grew organically. And what JavaScript did was said, okay, well, we are going to have a community just like PHP. Anyone can contribute things to the JavaScript programming language or JavaScript language, the JavaScript framework, any pieces of that. And JavaScript started also going out to the front end with just JavaScript, operating on servers in Node. So you could run purely JavaScript applications on servers, computers, anything you wanted. Then big corporations also saw this and said, you know what? We want to participate in this community. I like to think for the good, but we can discuss those merits later. But larger corporations like Google and Facebook came in and developed frameworks within JavaScript. Frameworks like Angular. Angular was created by Google. Frameworks like React. React was created by Facebook. They took all of these JavaScript functionalities and put them into frameworks within JavaScript, which then took us into, with those frameworks, we needed new names and specifically new acronyms. And a lot of the JavaScript frameworks would attach a different kind of database to it in Mongo database. Mongo is a NoSQL database versus MySQL, which with its name is a SQL database. And these frameworks we got to add letters to and call the mean and MERN stacks. There are many, many, too many to count, other JavaScript stacks, but this was the general evolution of it. All of this revolved around the package function that JavaScript had. The package function was basically, you could write a piece of JavaScript code that found the lowest number in a list. That's all it did. Someone building their website in JavaScript would say, you know what, I need to find the lowest number that comes from this list. How can I do that? Well, there's a package out there for that. You can install that package that someone else coded and maintained and download that via a product called NPM, which is open source, to install that package. And then you would use that package in your application. You had no idea, by the way, you could, but you had no idea where this package was getting other packages from or where those were getting other packages from. And this goes again to, we've got code on top of code on top of code, all the way down. This package framework allowed more creative people, people that weren't as versed on how to program and compile an application, to say, you know what, I have no idea how I'm supposed to send an email or how I do a notification. Well, I can just get a package for it and that will be part of my plumbing. So all of these functions became known as plumbing framework within your overall application. During this time, and this is one of the areas where just a year ago, I came into trying to understand where market trends were heading, where application trends were heading. I thought here, everyone is using this new framework. It's JavaScript. It's JavaScript all the way down. You know, all new applications, all new sites, all of them are done in JavaScript, and they're using a mean stack or a MERN stack or a SQL database or something along those lines. And all during this time, all of these modern stacks, there was the LAMP stack still, and that was still hanging around and still expanding because of the button. One guy that we talked about before, not necessarily just one, but WordPress. So WordPress is the killer application of the LAMP stack. Pretty much all WordPress installations run on top of some form of the LAMP stack. MySQL has been replaced with MariaDB, but it is all still LAMP. And by some estimations, LAMP, PHP account for 80% of all of the sites on the internet. 80%. So all those other stacks that are out there, they're awesome. They do incredible things. You can do incredible things with them. But 80% of the stacks that are out there are still LAMP based. And I'll show you in just a sec, WordPress based. I know most of you know what WordPress is, but for those of us out there, WordPress added another layer where it took all of the HTML that you needed to build your site, took all of the pretty formatting in CSS and those types of things, and it put a GUI on top of it so that you could drag and drop and create your website from scratch very, very easily. This was done originally in response to a trend at the time in the 90s, which were diaries that people were keeping on the internet called blogs, virtual or weblogs, I think is what it originally stood for. But created that framework so these people that were just writing about themselves, this was the Twitter before there was Twitter. They could just write about themselves, throw it up on a website, and everyone could access it, for better or worse. You know, we've all seen we've all seen some interesting things out there. This was all interesting and all incredible in terms of what you could do with it. That's great. You could drag and drop it, but corporations and larger institutions ignored it. WordPress was, you know, you don't use that. We have 50 developers and 20 engineers that all take care of our code, our website. And these developers and engineers would develop new products and features, and the release schedule would turn into going to a change control meeting and convincing people that you needed to make this change and what the rollback was and all of those things. So no one was moving quickly. It all took its time. You had to go through the proper process, and then you would get it approved and go out there, and invariably it would break and you had to roll it back again. So change was definitely slower during this time. But coming to the other side of things with WordPress again, there was this entire community and user base that was developing features and functions for WordPress and rolling them out quickly, testing them quickly, creating new sites very, very quickly. And with the advent of the cloud, like we all talked about before, you know, Amazon bringing their S3 and EC2 instances, you could spin up these sites very, very quickly and be ready to go. And you would pay very, very little for them. And this started an explosion into all of these sites running and being created. With the cloud, you got to like my graphics. Some of them are blurry. So with the cloud, another thing started to come into focus also. There was an often overlooked group of people that were kept in the basements of most companies. They were not provided with sunlight. They grew like mushrooms, and they were kept alive on Mountain Dew and Doritos. And these people were the systems engineers or sysadmins that kept all of these websites running, including the WordPress sites. What I just talked about a moment ago about the process that it took to upgrade or change a monolithic application, these guys would have to come up with the way to do it, implement it, and then, like I said, roll it back if it didn't go into effect right. What a lot of these guys and girls, excuse me, it is unfortunately still a male-dominated world, but I think it'll become much better as we get more and more women involved. We need to get out into the sun more, that is for sure. What happened was a lot of these people found ways to say, you know what? Every time this site goes down or every time this application breaks, I have to bring it up in the same way each time. Why am I manually doing this each and every time? Why don't I just write a script that does it? And then that way, when the site goes down, I just run the script and then it fixes it and it's great. Or I'm rolling out many, many, many different websites. And every time I roll out a website, I'm doing the exact same thing over and over again. So why don't I just create a script that builds that website the same way each time, and I don't have to worry about it. So this type of automation and creation of these tools has come to be known as one of many things, but has come to be known as a DevOps type of culture or a CI/CD type of culture. These are two kind of different things, but let's just unpack the definitions real quick. DevOps, a set of practices that combine software development and IT operations. All right, that's pretty generic. You know, that's a nice thing to say. And CI/CD, the practice in software engineering and continuous integration and continuous deployment. I always love it when they use the same words in the definition that are part of the acronym. These concepts, essentially, you can see from the graphic, are just a way to do an automated and continuous creation, testing, release, test again, bring back. They all have a common operator from the standpoint of it all needs to be done automatically, including testing. It needs to be deployed automatically, often in what has now become known as a canary deployment, which means put it onto this new service. We're going to put onto 20% of our systems. If they explode, then we know we have to take it back again. If it doesn't explode, then we can roll it out to the rest of them. All of that automated and taking those numbers that we get from it and saying, okay, this is a successful release. This is not a successful release. Let's do it again. And from a developer standpoint, what it's also often meant is that every single small code change that is made should be pushed into this release pipeline as quickly as possible. So maybe you're changing the color scheme to a website. Maybe you're changing the text in a certain area. All of these things get committed immediately via GitHub service, GitLab service, tested, pushed into production. And that's really the idea behind a DevOps CI/CD environment. Now, to expand this a little bit more, there's a piece that we are missing, which I like to refer to as the human stack. So we've had a technology stack to this point in primarily talking about our LAMP stack or our mean and MERN stacks, but we also have a human stack. And one of the big pieces of the human stack, take all of these different methodologies, is putting a framework on top of the code that we're developing as well, and the people and processes that we develop that code with. All of these frameworks that are out there now, Agile, Scrum, Lean, all of these fun buzzwords often usually just harken back to an older management concept called Toyota Production Systems, but this isn't a management class, so we're not even going to dive into that. What these frameworks with the human stack put on top of our already established technology stack is the way to find those approval processes that we went through with the awful change control platforms, to increase the speed, we often say velocity, in the rate at which code is thrown out into production. And all of these concepts and frameworks, from a tooling standpoint or a human stack standpoint, had the promise of boiling your entire IT team or development team into a velocity number. So you could take everything that you were producing and you could determine that velocity number, and that was going to tell you how much you could deploy every month, how many features you could throw out there, how much capacity you had from a development standpoint. And this started to bring in the change from traditional quote unquote IT shops to Agile shops and Scrum shops and all of those fun acronyms that we've come up with there. The next step that we just want to take in our background journey is we've got the cloud, we've got our tech stack, and we have our human stack and our management stack. And on top of that, we want to bolt on the additional technical functionalities that come into play with the concepts of microservices, serverless, APIs, all of those fun things. But what has started to happen at this point, and what is happening now, is that with the combination of these stacks, we get application development and implementation changes from the standpoint of application components and website components are broken up into their constituent functions. So you only have a function that handles notifications. This, by the way, is Uber's official application environment or containerization environment. The notification piece has a team that works solely on sending emails, sending SMS messages, doing push notifications, and it takes its data and its pieces from all the other components to just do that notification piece and expand into making sure that that notification piece is running all the time. It's highly available. It's infinitely expandable, so it can handle any workload you throw at it. And it is all accessible via a standard messaging format in an API set. So any new product or module that is developed from Uber's standpoint would just say, okay, instead of writing my own notification service to go with this, I use this notification service and I access it via an API. I tell it to send a notification and it does that. So with that, now that we have all of these different layers, again, remember we started with HTML running on top of an Apache web server. We've added many more different piles of tech and code on top of it. Is this the modern framework? Well, to a great extent it is. But it has also turned into something a little bit interesting that I heard us talk about before. I'm sorry you probably can't read these things, but the modern framework of that DevOps approach and CI/CD approach, the constant release, constant coding, constant testing, all automated, has led to an application layer. And what I'm showing here is these are all the application frameworks, not all of them totally, there's plenty of others. All of these application frameworks that we're now putting on top of our already huge pile of code. And all of these applications perform a different function. They might perform an observability function that we've since lost because everything is getting abstracted away from the underlying system. They might display simple analytic structures. They might handle release in a particular category or code changes and bug tracking and all of those different things. We've managed to add code on top of code on top of code with applications on top of code. So we're getting a few layers up there. And with this, again, like I mentioned, this is the modern, more or less, the modern application framework. Does it work? To a great extent, it does. There's plenty of companies doing things in this manner that have created great products and services, great applications, embraced all of this. But interestingly enough, during this entire time, like we talked about before, there was still this guy. There was still WordPress hanging out, still there. I don't know why. I've been trying to figure it out. I think it's great. But WordPress and the LAMP stack continued in the background the entire time, to the point where in these numbers, I know you probably can't see them too well back there, but starting in January in 2011, all of the frameworks that were not WordPress accounted for 76% of the sites that were out there. So someone wrote it, someone coded it. They didn't use WordPress for it. Come to 2021, those other frameworks, some of them JavaScript frameworks, some of them plenty of other frameworks, have come down to 36.4% of the total sites that are out there not running WordPress. Where at the same time, WordPress in 2011 accounted for 13% of the websites and applications that were out there. And in 2021 has increased to 41%. I find that pretty interesting. Some of the interesting things, the really interesting things that I find around that are that WordPress didn't just ditch or not acknowledge these other frameworks that came up, these other technology stacks. WordPress kept itself in the middle, greatly serving web pages, doing its thing. You know, it does its thing great. But at the same time, having the community that we talked about before around JavaScript, WordPress has that same type of community, a huge community of developers and contributors that create products for and plugins for WordPress. They continued down the line of saying, we want to keep using WordPress for whatever reason. By integrating a lot of these newer concepts into WordPress, like a DevOps CI/CD pipeline, there are people doing that with WordPress. Implementing WordPress to only carry the business logic and systems logic, acting as the central repository and turning it into what's called a headless format in bolting on JavaScript to do the front end in some framework. JavaScript then talks to WordPress to get its functions and display its pages. So totally new skin to the front, not WordPress related, not PHP. Doing all of these things, they also found out pretty quick, which I know many of us have that work with WordPress. They found out WordPress is great, but it doesn't scale necessarily too well. Interestingly enough, over the past 5 years, a lot of the issues that have been found in WordPress and scaling, there have been a number of companies that have contributed and written open source plugins to help with those things. So I would call them kind of advanced concepts around the lines of database performance. So when a database gets too big, it gets really hard to get the information out of the database that you want. People have written plugins for WordPress to handle database sharding. And sharding is the process of splitting out your database into more manageable pieces. Some of the largest caching layers, players like Redis and Solr, where queries that are used over and over and over again are kept in really fast memory. They have written functions and plugins that operate within WordPress to make it better and make it quicker. And on top of that, there have also been the high availability initiatives that they've written into WordPress, where instead of just having a single database server or a single front end server, you can have many. And if you put the HA or high availability piece into it, you can then distribute that across many areas. WordPress has also embraced all of the cloud functions that we hear about, we heard about before. The ideas of S3, which is object storage. S3, obviously, the term was popularized or is from AWS. For us older people, S3 is like VHS. Yeah, it was a product at one point. Now it's become a standard. So we all use S3. And one of the things that S3 is used for quite a lot is to take all of those images that you would be using on your WordPress site, put them into S3 containers, and replicate those containers in folders to many different areas around the world, around the US, so that your overall performance is much quicker. So farming off that CPU intensive task of delivering images and putting it into an S3 concept. I've found that hugely interesting. It's been an interesting dive into talking with a number of you and a number of big WordPress shops that say, we are hitting these limits here. What can we do? And examining this more and more, it's been very interesting to me. With that, I want to come back to the human stack real quick. I like that reaction. That's what I was looking for. But the concepts that I talked about before in DevOps, Agile, Lean, all of these different frameworks, they all started from, not all, but they started from the Agile concept, which was actually written as an Agile manifesto by a number of developers and project managers that said, you know what? We want to do stuff. We want to create programs that we can do fast, that we can bring to market quickly, and that we can simply update or implement a plan to do it as quickly as possible. This original Agile manifesto and framework was five lines, not even complete sentences. There's 5 lines. Since then, Agile has been turned into this. This is from a popular consulting company that I won't name their name. But this consulting company has said, you know what, if you want to put an Agile framework into your development shop, it has to encompass this. It's not quick time to market. It's not rapidly deploy, fail, try it again. It has 10,000 steps, who knows at this point, in order to do that. And one of the things that I take from that is, we all of these frameworks and ideas, they had the best intentions when they started. They all had great key points that we were looking at, and we said, yeah, we should be able to do this quicker. We should be able to release things and not worry about blowing up everything. We should be able to do all of these things. But along the way, they evolve into some type of commercial product like we saw before and go down those lines. So with that, what I want to talk about is my 5 points, which obviously only came from me. I didn't steal these from anyone. But the 5 points that I've actually seen out there that go into creating a good development shop, a good company, a good team, in order to create those iterations and fast software productions. I think it's pretty straightforward, but empowerment, starting with the first one, giving your team the overall guidelines of what you're trying to accomplish, but leave the specifics up to your team members. Empower them to make those decisions and empower them to make the mistakes that they need to make in order to figure out how the technology is going to work. Accountability. Accountability can often get confused with who's to blame. That's not what accountability is. I always like to say, whenever we were in some environment, someone would make a change and we got to break out the blame thrower in order to figure out who's going to burn for it. So accountability from a real sense is, you know what, if you break it, you bought it. You and your team have to fix it. You're responsible for it. You can't just throw code over the wall, hope that it works. And then if it doesn't, you're like, well, I don't know why it didn't work. It's accountability takes it to that step where you need to lead up fixing that. Ownership. I take a little bit of a different definition of what ownership is in this particular equation. Ownership to me really means, from a customer standpoint, and we all have customers, whether it's internal customers, whether it's external customers. But from a customer standpoint, understanding that you are asking me, I want a WordPress site that's going to serve 5,000 concurrent users and is never going to go down. Okay, well, that is exactly what you need. That's exactly what you're asking for. But I go through it in my head and I say, you know what? I think what you're really looking for is something that's more high availability, something that can scale real well and take care of all those things without spending 25 grand a month doing it. So I'm not going to give you, or I don't want to give you, exactly what you're asking for. I'm taking the business problem and saying, okay, I need to figure out how you're trying to achieve those goals. And is this really the best route? I think you might be better served going this route. That is the ownership of the problem, not just shipping out what exactly a customer asks for. Observability. This is also interesting to me. We were talking a little bit about this before, but observability into the underlying environment and how it's running. So everything from your code, how your code's running, to the underlying operating system. One of the things with managed services and what we've entered into as infrastructure as code, infrastructure as code is the concept of pushing your application out and all you have to do is define it all in a file and it magically happens. Um, Pieces of that observability have been lost. So there are many services out there. Everyone has them, AWS, whoever, it doesn't matter. They have functions as a service where you have a particular function, you upload it to AWS, and it runs that function when it's called. And you set the amount of CPU, RAM, and storage you want that function to use. You're guessing at that point. You don't know what it's going to use. You don't know what it's actually going to look like and what it's going to do. With a lot of these infrastructure as code implementations, what has happened is that you have given your function the maximum amount of RAM and CPU and all of those things, but you don't understand why it's still running slow. You don't have tooling without implementing one of those large application stacks to figure out why it's running slow. So an interesting, what's old is new again, is that a number of customers have actually come back and said, you know what? I'm actually going to have to get down to the operating system level and I'm going to have to see what's going on there, not all the way upstream at the application level. I need to tool my operating system so that I know what's going on and I can figure out where the issues are. So I found that an interesting trend. And again, all of these functions as a service becoming the mainstream, but we don't know why they're running slow. So now we need to come all the way back down the stack and start looking at what's going on from the operating standpoint. And finally, in honor of the United States supposedly launching another large rocket today, I don't know if it went up yet. Maybe it did. Anyway, it's always a bug. So I'm a space nerd, and the Apollo program, which brought Americans to the moon, there were a whole group of individuals that program is one of the most amazing things you can ever read about in terms of system engineering. But one of the concepts in it came from some of the people involved with it, the big engineers. And that big concept was test to failure. I found this very interesting. Don't just take your site and say, you know what, I think I'm going to have 20 users on this site all the time. I'm going to test it for that, load test it for that, throw some nice scripts at it. Yeah, it looks good. Everything looks good. I'm sure all of us can remember some beautiful releases of things like the Affordable Care Act site or a number of other government websites that went out there and it's like, oh, we're overloaded. We can't do anything. No one can sign up. There was no testing to failure there. In rockets, they would test a failure because rockets had a nasty habit of blowing up if they didn't go right. So they would test the entire stack of that rocket and say, you know what, let's push it all the way to the limit and see where it blows up. From our standpoint in a technology world, that speaks directly to, I'm going to hammer my site with thousands of users until it stops responding or the machine blows up. I want to see where it dies. Does it die at the network level? Does it die at the database level? Does it die at the API level? I want to know where that thing sits so that I can make the changes that I need to make. And it gives us so much insight into those things. So I really like that one. And hopefully that rocket will go up. Although I like SpaceX now, obviously. So Along those lines, I just wanted to finish with, like I said, I wish I came up with all these things. They're not my insight. I take them from many, many different sources. But one of the biggest sources is Netflix. Netflix has a very interesting environment. Um, really, really briefly, the the Netflix ethos is that any developer that comes into Netflix can have full-blown production access. You just need to ask. So I could start there tomorrow. You can have full-blown production access. Even if you kill what you're working on, you get full-blown production access. They build teams. They don't necessarily, according to them, build products. But these teams, they have those trust and accountability and iterations and the understanding to the extent that if you blow it up, you're going to have to go fix it and you're going to figure out how to do it. Along those lines, one of the quotes I've always liked from Netflix is from this is actually attributed to one of their lead engineers, Dave Hahn, who said that we don't practice or do DevOps and CI/CD. It's just a description for the current interactions and toolings we do as developers and engineers. It's not a religion. So in closing, I would say build that team, trust your team. If there's some functions that you can snap onto that help you, that are from Agile or Lean or any of those, that's great. But in the grand scheme of things, it just takes that trust and ownership that we talked about before. And with that, I'll leave you.